when I went to my, I got to turn off my, let me get a new movie recording of me here in the corner. When I went that the Olympics are tonight, and of course they sell the Winter Olympics through the ice skaters, and it's always kind of funny to me how we get wrapped up into a little, I'd probably not know, and to it's Valentine's Day is coming up. Let me get rid of this, and two, we get all excited. Oh, I didn't mean to quit. I don't follow skiing. I do follow. All right, now here is an ugly problem. All right, I'm just gonna be flat out honest with you. This is one of those ones where if you're not used to this kind of stuff, it will mess with your head. All right, but we're not gonna let that happen. Because, all right, I want to find the tension in these two rows. This is a picture hanging in equilibrium. That helps. Equilibrium, big word. That just means the acceleration is zero. It's secured. These are two things secured to a wall, say, or to two walls. Okay? So, here's what we know. I know that I break it down into two pieces. The sum of the forces. I just kind of realized something. Maybe I lost. Oh no, here they are. Here's on the sheet. I thought maybe I'd lost the sheets for the tension thing, but I didn't. All right, so some of the forces in the x direction, they equal zero because there's no acceleration. Aha! Well, let's take a look. We just break these guys down into their components. So here, T1, here's T1x, and here's T1y. Well, T1x is equal to minus T1. What I'm trying to find is T1 and T2. I got two unknowns here. Well, T1x is equal to minus T1 times the cosine of 40. But there's another. There's T2x and T2y. Now we've got all the forces. They all add up to zero. We're just going to play with them. All right? So we go, okay, well then plus T2 cosine of 20. All right. And that equals zero because the acceleration is zero. Okay. So now I know this. I know that I can solve T1 cosine of 40 is equal to T2 cosine of 20. Ergo, T1 is equal to T2 cosine of 20 divided by the cosine of 40. Those are funny looking numbers for right now, so I'm not going to substitute them in. But I've got a turn for T1 in terms of T2. And I got a whole other set of things to look at. So this is great. So I'd say, all right, well, the sum of the forces in the y direction, they're also equal to zero because it's in equilibrium. AX and AY are both zero because it's just hanging there. All right? And I know that the mass of that is 10 kilograms. So I'll look at Ty. So I've got T1y, T1 times the sine of 40 that's one force is going up, plus T2 sine of 20 minus mg. All of that is equal to 40, or all that's equal to 0. Okay, I am ready to solve for T2. And then I'm going to plug it back in and get T1. So here we go. I know that T1 is equal to this. So I'll say, okay, T2 times the cosine of 20 divided by the cosine of 40 times the sine of 40 plus T2 sine of 20. I mean, these are just numbers, minus mg. All right? Let's make that T2. So I've got 10 times 9.8, so then I add mg to both sides, so that goes away, is equal to, I'm going to clean this up, sine 40 divided by the cosine of 40, that's the tangent of 40. If you don't remember that, it's no big deal, because you can just plug in all the numbers later. T2 cosine of 20 times the tangent of 40 plus T2 sine of 20. Now, I still haven't plugged any numbers in yet. Why? Because I can do something miraculous here. I can pull a T2 out of here and get the cosine of 20 plus times the tangent of 40 plus the sine of 20. I just factored the T2 out and I get a number. And so T2 is equal to 98 divided by all this mess here. And all that mess there, let's go ahead and run it. It's not that hard, see? Now that we've got it, it doesn't seem that hard. So we've got cosine 20 times the tangent of 40 plus the sine of 20 is equal to 1.1305. Let's go with that. 1.1305 is all that mess. Okay? So T2 is equal to 98 divided by 1.1305. So I'll take 98 divided by my answer. Whoops, better hit divide by. Divided by my answer, they'll take this answer here. Bang. 86.7 newtons. All right. Now, I just solved for T1. My phone is blowing up. Solve for T1. Well, T1 is equal to 86.7 newtons times the cosine of 20 divided by the cosine of 40. So here we go. 86.7 cosine of 20 divided by cosine of 40, 106.35. So T1, because it's, and that makes sense because it's a bigger angle. If T1 was going this way and T2, like straight up, it would be holding most of that up, right? T2 wouldn't be adding much at all to the thing. So that makes sense. Good. One more.